Sequence is a function which maps each natural number to a unique element belonging to the set S. Symbolically, it can be represented as f maps set of all natural numbers to a set S. If capital S equals set of all real numbers, then we call the sequence as real sequence. Sequence can be represented using these two notations, or we can make use of curly brackets an or curly brackets xn to denote sequence. We have f suffix 1, f suffix 2 and f suffix 3 will denote first, second and third terms respectively of the sequence fn. Whenever we have m not equal to n, which means that m and n denote distinct positions. Corresponding to these positions, we have f suffix m and f suffix n are mth and nth terms of this sequence. Even if the value appearing in mth and nth position of the sequence, that is, even if the terms fm and fn hold same value, in that situation too, we will treat f suffix m and f suffix n as distinct terms. For example, if you consider the sequence xn, where xn, which is the general term, equals minus 1 the whole raised to n, then we have sequence xn will look like first term will be minus 1 the whole raised to 1, which becomes minus 1. Second term x2 will be minus 1 the whole square, which equals positive 1. Third term will be x3, which is obtained as minus 1 the whole cube, which equals minus 1. Fourth term will be x4 equals minus 1 the whole raised to 4, which equals positive 1, and so on. We will have x1 equals minus 1, which is the first term, x2 equals positive 1, which is the second term, x3 equals minus 1, x4 equals positive 1, x5 equals minus 1, x6 equals 1, and so on. Here you can see that x2 and x4 are having same values, which equals 1. Still, since they are holding different positions, they will be treated as distinct terms. Similarly, we have x1 equals minus 1 and x3 is also equal to minus 1. Even if these two terms x1 and x3 hold same value, they will be treated as distinct terms itself. Range of a sequence is set of all distinct values of the sequence. Here we have 1 and minus 1 are the distinct values, and hence the range of this sequence will be 1, minus 1. Notice that sequence xn consists of infinitely many terms. This is because sequence xn consists of n positions where n belong to set of all natural numbers. Since set of all natural numbers is an infinite set, there are infinitely many positions or infinitely many terms for this sequence xn. Thus we have this set is an infinite set, but the range set of the sequence, which will be set of distinct values, is equal to 1, minus 1, which is a finite set. Similarly, we have another example. When you consider sequence xn, where each term xn equals c, where n belongs to set of all natural numbers, which means that first term x1 equals c, second term x2 equals c, third term x3 equals c, and so on. There are infinitely many c's which comprise the sequence xn. Thus, we have this sequence is an infinite set. When you consider the set of all distinct values, we have the range of the sequence will be singleton set C, and which is a finite set. From these two examples, it's clear that even if the sequence is infinite, the range set can be finite.